This video will go through 3 examples of finding equations for sine and cosine functions given a graph. Here I've listed the different pieces you need to find using the graph to come up with your equations for sine and cosine. As you'll see in the examples, the only difference you'll see between the 2 equations you create will be the horizontal translation h. The amplitude will be the same between sine and cosine, b will be the same because the period will be the same, and the vertical translation will be the same. Keep in mind, as we've discussed, that instead of writing y minus k, you could write y equals and then have plus k tacked on at the end. It seems most of you are preferring that, which is totally fine. Let's look at our first example. Keeping in mind we're going to find the axis of wave, which is k, or y equals k. To do that, I'm going to go through each of these steps. We're going to find the average, basically, of the max and the minimum y value. We're going to need the amplitude. We can do that by doing the difference between the max and the minimum divided by 2. We'll need the period, and from there we'll calculate what b is. And then we're going to need to figure out the horizontal translation for cosine and the horizontal translation for sine. So let's do our first example. Don't forget to write these different steps down in your notes and take detailed notes on the next 3 examples. Here's our first example, and it's very important that you have this graph in your notes. Please make sure that you have some of the points labeled, such as -1, 1, 0, -2, 1, -5, right? We need some of these. 2, -2, 3, 1, and so on. You don't have to have as many periods as I have here, but you have to have at least 1 full period. I also recommend you have the point -2, -2 on your graph. So pause the video to recreate this graph in your notes. Now that you have the graph, let's go through the different steps to find the pieces we need to create our equation. I've listed the sine equation above, but please keep in mind the only things that will change for the cosine equation will be, of course, that this will say cosine instead of sine, and this horizontal translation will be different. A, B, and K will all be the same. So let's start with the axis of wave, although there's no right order for the steps, okay? But the first thing I listed was finding the axis of wave, which is k, or y equals k, so let's start with that. You may be thinking you don't need a formula to find the axis of wave. You can just see that it's going to be halfway between the max and the min, which is exactly what the formula does. If I do half of the max plus the min, I'm getting the halfway point, or technically the average, of those 2 y values. So if you've already just noticed that what the axis of wave is, great. I do want to show you that the formulas can also help you with that, but you don't have to use the formulas. So if I do 1/2 of the max plus the min, the y maximum value is 1, so it would be 1/2 of 1, and the y minimum is -5, so 1 plus -5. And half of -4 is -2, so our axis of wave is at y equals -2. It's very helpful to draw that in, so do that now. And again, visually, we're probably able to see that the axis of wave was at y equals -2. The second piece listed was finding the amplitude. Now that I have my axis of wave drawn in, I can just count from the axis of wave up to a maximum, which is 3 units, or down to a minimum, which is also 3 units, and so my amplitude is 3. I do want to also show you that if you had a much larger graph where maybe the amplitude is 47, it would be harder to count, and so you might want to use the little mini formula. So I'll also show you that that will also give us 3 for the amplitude. So if I do half of the quantity, the max minus the min, max again was 1 minus the minimum was -5. You can see I actually get 1 plus 5, which is 6, and half of 6 is 3. So the amplitude, as we already noted, is 3. Now we'll find the period, which you can find different ways. If I go from crest to crest, or max to max, that's usually visually the easiest to see. I have to count, first noting my scale, What is the distance between these two maximums? Well, the distance is 4, so the period is 4. Please remember, b is not the period, but I can use the period to get b. So again, if I go from max to max, the period is 4. I also wanted to show you that we have other curves hiding in here. Maybe you're thinking, oh yeah, here's my cosine curve. But there's also a sine curve. If I start here and go up, do the maximum and then the minimum, that was a sine curve. And if I go from the start to where it starts over there, that distance is also 4 units. Or maybe you've noticed there's a negative cosine graph. If I go from the start of one cycle of the negative cosine graph to the start of another one, that distance is also 4 units. So it should make sense that the period is not going to change depending on where you locate it. Now that we know the period is 4, I can use that to get b. So you might remember that the period is always 2 pi over b. Well, b, therefore, is always 2 pi over p. So in this case, that would be 2 pi over 4 or pi over 2. So b is pi over 2. The only thing left to find in our equations are the two different horizontal translations. Let's start with the horizontal translation for cosine. I've just labeled that as h cosine. There are actually an infinite number of horizontal translations. So I could say that I have a cosine graph that's been translated 1 unit to the left. There you can see I'm starting at my maximum, going down to the minimum, and back up to the maximum. So I could say that the horizontal translation is -1. I could also say the horizontal translation is +3. I could say that one of the cycles starts here, and from here at 3, it goes down to its minimum, and then it will go back up to its maximum. That's not on this picture, but that's still a valid horizontal translation. So I have more than one option for my horizontal translation. I'm going to just say that it's -1. If you write down on your paper that it's 3, we are both correct. I could also talk about a negative cosine curve, and if I wanted that, then that would technically, one cycle would start here. So if I wanted to say a negative cosine curve, which would look like this, I could say the horizontal translation for that would be 1. So as you can see, I have a lot of options. Let's go on to sine. Remember, sine starts on the axis of wave, goes up to its maximum, back to the axis of wave, down to its minimum, back to the axis of wave, where it would start over. So I could say that the horizontal translation, if I wanted to use this point, would be -2. I could also say that the horizontal translation is +2 if I wanted to say that it starts here. Both of those answers are correct. For this one, I'll say +2. For the record, I could have also talked about a negative sine curve, in which case there is no horizontal translation. So if you don't want to have an x minus h in your equation, you could say it's a negative sine curve, which actually is starting without a horizontal translation. Let's put our formulas or our equations together using these different pieces. I'll start with sine, which I have up here. So I'm just going to go fill in a, b, h, and k. So here's my first equation. I filled in that the amplitude is 3, b is pi over 2, which I got from the period being 4. The horizontal translation that I chose was 2, so that's x minus 2, and k, which we found first, is -2 as well, or -2. Just for kicks, I'm going to write a second sine equation. I'll use that negative sine equation that I talked about. So for that, it would be, so here's another option, y equals -3 times the sine of pi over 2 times just x, because we said that if it were a negative sine curve, there was no horizontal translation. So this is another option, but then I also have to remember the -2 for k, so it's not grouped in with the x value. It's tacked on at the end. Sorry that it's a little squished there. And finally, I'll create my cosine equation, which I can repeat a lot of. So it's still 3. Don't forget to put cosine instead. The b is also still the same, but my horizontal translation was -1, So I will write x plus 1 in parentheses and minus 2. So you can see they're very similar. That's our first example. I went through that in way more detail than I planned to do the next two. So let's look at the second example. So again, the first thing that I will find is the axis of wave. Maybe you can visualize that it's going to be at y equals 2, so k will be 2, which is what you'll get if you do 1/2 of 6 plus -2. So half of 4 is 2. My axis of wave, again, is at y equals 2, so k is 2. I'm going to draw that in. Next, I'll find the amplitude. Again, I can just count from the axis of wave up. That's 4 units, so the amplitude is 4. If I go down from the axis of wave to the minimum, that's still 4, or I could use the mini formula. Any way you slice it, the amplitude is 4. Next, we'll find the period. I like to go from max to max, so if I look at the x-coordinate of the first max that I see, it's -pi/4. So I'm going from -pi/4 over to 7pi/4. From -pi/4 to 7pi/4 is actually 8pi/4 or 2 pi. So I'm technically taking 7pi/4 and adding another pi/4 on to the distance. So the period is 2 pi. Since b is always 2 pi over p, in this case b is just 1. The last thing I need to find is the horizontal translations for both cosine and sine. Remember, there's more than one correct answer for the horizontal translation. I could start from this maximum, in which case I'm saying the horizontal translation is -pi/4. I could start from the next maximum, in which case I'd say that h is 7pi/4. I could look at a negative cosine curve, in which case my h would be -5pi/4 or 3pi/4. I'm going to go with the one closest to the x-axis again, which is -pi/4. But if you say that your h is 7pi/4, you are as correct as I am. And for sine, we also have options. Remember, you need to look on the axis of wave, where is sine starting and going up to its maximum. I could say that the h for sine is -3pi/4. I could also say it's 5pi/4. If I wanted to use a negative sine curve, I could say that it's pi/4. I'm going to go with -3pi/4 for my h for sine. Now that I found all the different pieces, the only thing left is to substitute them into the two different equations. Remember, only h and changing sine to cosine will be different. So I'll write those up now. And there you are. There are two possible equations for this graph. There is, in fact, an infinite number of equations for this graph. We've listed 2 of them. Final example, I'd like you to try it yourself first, and then you can see my steps. So I recommend that you, of course, recreate this graph in your notes, as you should have done with all 3 of the examples. And then I would just pause the video to try and figure out the pieces yourself, and of course, check back in to see the different steps. I'm actually just going to list out the different steps since I've already done 2 in great detail, and this is getting long. I've listed out the first few steps, but this one, the period, you might have a little more difficulty with it only because the values on the x-axis aren't yet labeled. That's okay, we know how to work with fractions. So if from here to here is pi/3, you can see that the maximum, which is where I'd like to start looking for my period, is halfway between 0 and pi/3. Well, half of pi/3 is pi/6. So this value is pi/6. I can then count in pi/6, or I could just jump to the fact that this is 6 pi/6, because of course it's pi, and I'm 1 more sixth past that, so I must be at 7 pi/6. But if you wanted to count it out, this is 1 pi/6, 2 pi/6, it reduces. 3 pi/6, 4 pi/6, it reduces. 5 pi/6, 6 pi/6, 7 pi/6. So the period, one period goes from pi/6 to 7 pi/6, which I've listed here. The difference between these would be pi, 6 pi/6. So the period is pi. From the period being pi, I'm able to work out that b is 2. The only other little tricky part might be the H translation for sine. You can see, hopefully, that since sine starts on the axis of wave, goes up to its max and then down to its min and back, that there's a horizontal translation starting here. Well, what is this distance? Well, we just worked out that every 2 squares is pi over 6, and I want 1 square, which is half of that, and half of pi over 6 is pi over 12. Since I'm in the negative direction, this point here would be at negative pi over 12, comma 1. So the H for sine, I'm going to use negative pi over 12. H for cosine, I'm going to use the one that we've already labeled as being at pi over 6. And now that I have all of the pieces, I'll write out my 2 equations. So here I have my 2 possible equations. If you had wanted to start your sine graph here, this is the last thing I'll say. Remember, each square was a 1/12 of pi, so this must be 12/12, which means this guy here would be at 11/12 pi. So an alternative for sine, you could have said that the horizontal translation was at 11 pi over 12. I hope you found this video helpful, and we'll do more practice in class.